What is going on, everyone, and welcome to the Fusion 360 tutorial series. This is day 3 of learning Fusion 360 in 7 days. This tutorial series is for complete beginners with Fusion 360 in order to learn the ropes from sketching our first component to assembling geometries by day 7. Today we will be taking a look at parametric modeling, what it is, and how it can greatly improve the versatility and flexibility of our models to make quick changes. We'll also be looking at some more modeling techniques, such as the shell command and taper command, all while modeling a customizable flower pot for whatever size plant you may need. Let's get into it. So what is parametric design? Parametric design is a modeling approach in computer-aided design where you can define dimensions, relationships, and rules, or parameters, that control the geometry of said design. This method allows you to create models that can be easily adjustable by changing the values of these parameters rather than having to manually alter them in the individual features. The key concepts to understand, and that we'll be talking a lot in parametric design, are parameters, constraints, equations and relationships, as well as history-based modeling. Parameters are the building blocks of parametric design. These are variables, such as dimensions or angles, that you can define and then use them to control features of your model. For example, you might want to define parameters for the length, width, and height of a box. You can assign values such as 100 millimeters, 50 millimeters, and 30 millimeters respectively, and then change them later on to instantly resize the box. Constraints, which we have briefly touched on before, are rules that define relationships between different parts of a sketch or model. They ensure that certain elements behave predictably as you modify parameters. For example, if you wanted to make a hole in this box, but want to ensure that the hole will always stay centered as you change the size of the box, therefore you would constrain the location of the hole or circle sketch to the center of the square or box. On the other hand, if you wanted the thickness of the wall to be a function of the width and the height to ensure that the pot maintains its structural integrity as you increase the size, this can be accomplished through the use of equations and relationships to allow certain parameters to be dependent on one another. Therefore, by updating the independent parameters, the dependent parameters will automatically be adjusted accordingly. This can also be useful to set limits within the equation to ensure certain model parameters don't become out of control. And finally, history-based modeling. This is the basis of Fusion 360, referring to the timeline that can be seen at the bottom of every environment. This allows for each feature and command that are used to be chronologically recorded. Need to go back and adjust a parameter earlier in the model? No problem. The subsequent commands will adjust accordingly to the new model without completely having to restart. Now that we have looked at the key concepts to look out for while using parametric design, let's put it to the test and design this flower pot. Before we begin sketching our flower pot, let's create some parameters that will control its dimensions. Parameters will also allow us to quickly modify our pot's dimensions without manually adjusting each feature, providing flexibility to adapt to any plant size. Therefore, to create these parameters, we will go to the Modify tab in the toolbar, press on the drop-down menu, and click on Change Parameters. This opens up the Parameters window, and here we can define user parameters and assign them values. To define a new parameter, just click on the plus symbol over here that says Add User Parameters. That will open up this menu here. We can insert the name of the parameter. Let's call it pot height. The units, we will keep it in millimeters, but by pressing on the drop-down menu, you could create a parameter for any variable with any units, as you can see. For the expression, let's set it to 120 millimeters for now. We will change this later on to show how we can make expressions that are dependent on other parameters and how our model will update itself as a result of that. But for the time being, that will be good for now. So we will press on the OK button, and we can see that our parameter has been added to the user parameter menu here. Let's go ahead and create a few more. We will add another parameter and call it pot top diameter. And let's set this to 100 millimeters. Press on OK. Now create another one called pot bottom diameter. And let's set this to 70 millimeters. And lastly, let's add wall thickness parameter. And we'll set this to 3 millimeters. And now we can close the parameters window by clicking on the OK button. And now we have all the parameters that we can need. So let's go ahead and start using them in our sketches, all while using the Loft and Shell commands to create this adjustable flower pot. The Loft command is a powerful tool that allows the creation of complex shapes by creating smooth transitions between profiles, otherwise known as sketches. In the application of this flower pot, we are going to use it to loft the area between the top and bottom surfaces. But first, let's create our sketches. So let's click on the Create Sketch button and select the XY plane as our sketching surface. We'll start by sketching the pot's bottom face. So choose the Circle command and snap the center of the circle to the origin of the environment. In the dimensioning box that appears, we will input the parameter name that we recently inputted, which is pot bottom dia. Click again, and now we can see that we have a fully defined sketch as noted by the black sketch lines, and it has a dimension of 70 millimeters. The FX in the front of the dimension shows that this is a function-driven dimension and not just a regular dimension we added while sketching. Press on the Finish Sketch button. And now in order to use the Loft command, we actually need to create another sketch that is on a different plane than the regular default planes that we normally sketch on. And we can use construction planes to do exactly that. Construction planes allow the user to input a plane in reference to the default planes or another 3D object to give additional surfaces to draw and sketch on. This can be particularly useful if the elements we are using don't align with the default environment. To find the construction planes, we'll go to the construction section of the toolbar and press on the drop-down menu. And as you can see, there are many construction functions that can be used for planes, lines, and points. But for the purpose of this video, we will choose the more common construction tools, the offset plane, to allow us to sketch on another plane that is some distance away from our initial sketch. So click on that, and this window will appear here. First, we need to select the default plane we made our first sketch on. This would be the XY plane. So we can see that this little dimensioning box appears here, and we can specify here how far we want the new plane to be from the old one. For the dimension, we will input actually pot height and then press on OK. Now with our construction plane created, we can make the second profile. So we'll go ahead and create a new sketch and choose the construction plane that we just added as the sketching plane. We will then choose the circle command again and snap it to the center of our environment. And for the dimension, we will input the parameter pot top dia, which is equal to 100 millimeters. Click again and press on the green check mark to exit sketch mode. And now we can see that we have our two profiles created for the top and bottom surfaces of our pot that are at some distance away from each other, also known as the pot height. Now let's use the Loft command in order to turn these sketches into a 3D solid. So go to the Create drop-down menu and choose the Loft command. That will open up this window here. Now we can choose our two profiles that we created earlier. And as we can see that the program has connected them together with some smooth shape. If we wanted to control the direction in which the profiles are connected, kind of like the sweep command, we could have used guide rails in order to do exactly that. But for the purpose of this video, we are just going to do a simple loft to show the functionality of this command. And as a little side note, we could have chosen many profiles that don't all have the same shape to use this function. So I encourage you to play around with it in order to see the powerful capabilities of this loft command. But for now, we are going to press the OK button to confirm the loft that we've created. And now you can see that we have a 3D body that is the shape of a vase. But now we need to hollow it out on the inside. And this is where the shell command can be useful. This command can be found in the modify section of the toolbar, and it looks like a hollowed out cube. If we press on it, this window will open up here. As an input, the shell command takes either bodies or faces. By selecting a solid body, the command will hollow out the inside of it, leaving all the outer walls intact. But in order to create an opening in the model, we can choose one of the faces instead. So for our vase, we will select the top face, since this is where I want my opening to be. And we are going to leave the shell type as sharp shell. For the inside thickness, this is referring to the wall thickness. So I will input the parameter we made earlier called wall thickness. And for direction, I'm going to shell it going inwards since I want to keep the outer wall. Press on OK, and there you have it. We have successfully hollowed out the middle of our vase while keeping an opening at the top so that we can put our flowers in it. Now with our model created, let's go back to the parameters page in order to see how they can be used in order to customize our plot on the fly. Go back to the Modify tab and press on Change Parameters. That will open up the window. And now we can see all the parameters that we previously created. And if we wanted to make a change to the base of the vase, make it more narrow, let's say, all I have to do is double-click the expression and put a smaller diameter, let's say 35 millimeters. And there you have it. Our vase has been updated according to the new inputs. Afraid that the walls are not going to be thick enough? Let's change this to 8 millimeters, and suddenly we have thicker walls. Now let's switch gears a little bit and return the discussion back to equations and relationships that we briefly discussed at the beginning of the video. I'm saying this because, I really like the design that I have here. I think it has really good proportions, and if I only change one of the values, as we saw earlier, it will kind of throw the whole design of our model off. This is where equations and relationships will come into play, because I can make a parameter an independent parameter, and I can create expressions so that all other parameters become dependent on that one parameter. So when I update the independent parameter, all the other parameters will also get updated, keeping the original proportions of my model that we currently have. So let's choose the top dia to be our independent parameter. And like we did to modify the parameters before, I will double click on the expression and input an equation that represents the value that I want. So our bottom diameter is going to be 70% less than our top one. So in the expression tab, I can type pot top diameter times 0.7. Click somewhere else, and as you can see, we've created an equation that gives us the same value that we had before, but now it's dependent on one of the other variables. Let's do the same for pot height. I'm going to double click this, and here I'll put pot top dia times 1.2 in order to get 120 millimeter height that we had before. Now for the wall thickness, let's do something a little different. As we update the model, I'm afraid that the expression that I'm going to create will cause the walls to be too thin at smaller sizes. In this case, I can use an if-else statement to ensure that this parameter does not drop below a certain value. So let's double click the expression. Here I'll type if and then select the if function that appears in the drop-down menu. This if statement is going to be broken up into 3 sections: the Boolean statement, the value that's going to return if it's true, and the value that's going to be returned if it's false, all of which are going to be separated by semicolons. So the statement I will use is if the top dia divided by 25 is less than 3, semicolon, I want my wall thickness to be 3 millimeters, semicolon. Otherwise, I want my wall thickness to be top diameter divided by 25. This expression that I have created will guarantee that my wall thickness will not drop below 3 millimeters as I'm updating other parameters, but will make the wall thickness 4% of the top diameter of my pot to ensure that the initial proportions of my pot are kept. Right now, we can see that the wall thickness is 4 millimeters, the same value that I had before. Now let's see what happens if I were to make my diameter 200 millimeters. And just like that, I have a flower pot that is twice as big while keeping the exact same geometry that I had before. Very cool. Now let's see if our if-else statement for the wall thickness is working. So if I put the top diameter to be 70 millimeters, I know that 70 divided by 25 is less than 3. So therefore, the wall thickness is below the minimum value I want, so the function should return the minimum value as 3. And by modifying the top diameter value, we can see that our model is updated with ease, and that our wall thickness is in fact 3 millimeters as a result of the if-else statement. Very cool. Congratulations on creating your very first customizable flower pot using parameters. So, that being said, that will be a wrap for day 3. Today we explored the power of parametric modeling, making our designs more flexible and adaptable. We also learned how to apply the Loft and Shell commands to create this customizable flower pot. Be sure to try out the different values and see how our model updates in real time. Watch out for day 4 of the Learning Fusion 360 tutorial in 7 days, where we are going to look into an easy way of creating nuts and bolts in Fusion 360 using the thread commands as well as several other commands to bring our modeling game to the next level. If you enjoyed the video, don't forget to leave it a like and subscribe for more engineering content.